In this video, I'm going to talk to you about a very important command that almost every cognition model implements, and that's the configure on unit command. This particular command is not ever initiated by an end user. So you see it's not in the list of available commands here. At least you shouldn't be. It's never intended to be initiated by a user. A user doesn't even know it's there. This particular command is actually not initiated internally either. This happens to be one of the Flames initiated commands. So the Flames initiates this command during scenario configuration. So I'm going to go over here to the script for this particular test unit that we've been using in these videos. So you can see I've employed our EXM cognition model and I've employed an EXM sensor model. And then here's the script for starting and initiating the assess command. We've talked about this in other videos, but let me just go over it for just a minute. Whenever any change is made to a scenario in Forge during scenario editing, the entire scenario gets reconfigured. And you already know about that from other videos. And that means that every single meta object in the scenario, among other things, every single meta object is configured. And then the units are configured. But before the units are configured, in fact, before anything else happens in the scenario, all the models attached to a unit are destroyed. So every unit in the scenario is wiped clean. Then all the meta objects for all the different models in the scenario are configured. If they return success from their configure method, so they configure successfully, they are available then to be cloned. And cloning takes place when we enter the employ statement. So this employ statement clones that cognition model, that meta object, and I can go click here and view, and you can see this. Here's the guy that's being cloned. And then I also clone a sensor model. So we execute all the statements above the start statement. So when the unit is configured, so all the meta objects have been configured, then we go to each unit, and when we get to the units, they have already been wiped clean, so there are no models attached to the unit. And then we process all the statements above the start statement. And whatever they might happen to be, could be commands to locate the unit, could be commands to assign formations, whatever it is that you want to do. It's up to you. It's all definable by developers and users, by developers especially. So I'm employing, but then after all the statements have been executed above the start statement, the very last thing that happens before Flame says, okay, unit configuration is complete, and I'm going to go on to the next unit, is it initiates the configure on unit command. And if that command returns failure, the unit itself generates an error, but the unit could continue. The unit might still exist, and because the units don't get cloned, so they're still out there. They still are marked overall as being configured. But if it's up to we'll see what happens when configuration fails. So the purpose of this command is to allow each cognition model that's attached to the unit to perform configuration while it's attached. So the cognition model as an entity model, it has a configure method. But that configure method is going to get initiated or going to get executed during the configuration of the meta object. So it's the meta object that's being configured. This is after the cognition model has been instantiated and it's been attached to a unit. So I have a unique instance of that cognition model attached to the unit. And then I want to be able to do an additional configuration after I've been attached to the unit. In other words, configure on unit while I'm on the unit. You might ask, well, what's the big deal? Why do I want to do that? Well, the reason it's a big deal is because practically every cognition model is designed to have some kind of interaction with the equipment models that are attached to the unit. They can interact with other cognition models, but primarily they're interacting with the equipment models. Just like a real human in a real battle or a real world situation, just like you in your car, you are driving your car, you're interacting with your car. You're listening to the radio. It's a communication device. You're not supposed to be talking on your phone, but you got a communication device and you can be communicating with other people. all the things that a unit the human needs to do in a player in the scenario for a unit. That's what a cognition model is doing. And so it's to do that, it's actually interacting with the equipment models that are attached to the cognition model. So the cognition model needs to find out whether or not the other appropriate equipment models are actually there. So in other words, has the unit been composed correctly? So we talk about this at great length, the overall issue of composing a unit, the composability, and how model interfaces play such a big role in us being able to validate the composition of a unit. So we're not going to go into detail on model interfaces, but we are going to see how this particular cognition model, like most cognition models, uses the interfaces to make sure that it is composed appropriately. And that interface checking is done in the configure on unit method. So we're going to go to the source code of the configure on unit method. And again, this is executed as a result of the configure on unit method being called, being initiated. The configure on unit command being initiated. Then it gets initiated as the very last step of unit configuration. Now it's common for cognition models to implement this method. And each cognition model that's attached to a unit is probably going to implement the method, which actually highlights another very important feature of cognition models and process methods. The initiation of a single command can actually result in the execution of multiple methods, depending upon which particular models are attached to the unit, which is also something that normal class methods can't do. So in this case, you may have 6 cognition models attached to a unit. They may all have configure on unit commands implemented, support for that command implemented. So when Flames initiates that command, every one of those cognition models is going to be given the opportunity to perform configuration steps while it's attached to the unit. So this is being executed for a specific instance of the cognition model, the one that's attached to the unit. So this is a very common thing to see inside of a configure on unit method. We go out to the unit and we make a call to say, give me the pointer to a sensor. So it's funit get equipment by interface. And I specify the name of the unit, which is a member variable of my cognition model object, which particular primary class of equipment I'm interested in, and what's the interface that it needs to support. So if it returns a pointer, that means we know that the sensor was there. And this is not a meta object. This is the sensor that's actually attached to the unit. This is this particular sensor right here, the one that's attached to the unit. If it's there, we save it. So this is a member variable of our class. So if I go to my definition here, I've got a variable right here called sensor. So it's the sensor model attached to the unit. I save a pointer to it so that for the remainder of the duration of the scenario, I do not have to go out and get the pointer to that sensor again. So I don't have to make another call like this, go out to the unit and say, where's the sensor? I already have the pointer. It's stored there and it's available for me to use. So when I go to my assess routine, I just start making calls for that sensor and I don't have to worry about it being set. It's guaranteed that sensor pointer is going to be set. I don't have to check it for it being null. I don't have to check to make sure it supports the right interface. And that's all because of this configure on unit method. I've already checked it. We know it exists. We know it's attached to the unit. We know it supports the right interface. So I save it as one of my attributes, and then I can use it for the remainder of the scenario. If it's not there, I will produce or generate this little message right here. So it says, I don't have the model that I need, that I am designed to interact with. It's not attached to this unit. And I go ahead and tell the unit the one that I want is one that supports this interface, so the user would know that we don't have, either it's the wrong sensor that's attached or there's no sensor at all. So there's no sensor that supports that interface. And then I set this little flag, and I say, and I do it like this rather than returning error, because there may be multiple tests in here. In fact, let me just show you. Let's go to the shooter. The shooter, actually, he has a configure on unit method as well, and he's looking for several things. So he goes out and he says, I got to have a data processor that supports this an interface. And I only check for the data processor if I'm in centralized mode. I don't have to have one. Oh, this is a communication device. I'm sorry. Then I look for a data processor. Then I look for a munition, and then I look for a weapon system. This comment's wrong. It should say weapon system. So any one of those particular things could fail, and any one that fails, I set this flag so that I can keep going and keep looking at the other things. I don't just immediately return failure. And so then down here, I will say bottom line cognition model will not execute. And then I make this little call right here, mark invalid. So I'm going to close this off and let me go back to EXM cognition. He does the exact same thing. He prints out this message, and then he says mark invalid. So that means that this particular cognition model, this unique runtime instance of the model that is attached to this unit, this model has been marked invalid. So what that means is that any command that is attempted to be initiated for that cognition model will not get initiated. So the unit is still in the scenario. The unit will still run. It'll still be out there. The other models attached to the unit might be running, but this cognition model is turned off because we know that we need this. We know that this sensor pointer has to be set to a proper sensor. So over here in my assess method, I'm assuming and depending on the fact that this sensor attribute value is set. So I mark it in valid so that I know that this particular process method will never get executed. I said I don't like it. I don't like the way the unit is composed. It's not going to get executed. So let's just go see what this looks like in our scenario. So I have a unit here. It's got commands, and right now I'm running. And by the way, when I'm running, you notice that I had that in a previous video. We said when it ran, it initiated the assess command, and assess initiated engage. So a little bit later, we saw the announcement coming from the engage method. So we're going to go over here and reset so that we can edit this unit. We're going to go to the script, and I'm just going to comment out this employee statement. And then I'm going to hit accept. So there's my message. No sensor is employed that supports the example sensor interface. The EXM cognition model will not execute for this unit. And then Flames automatically generates this error message. So we're going to talk about error messages and error and return values from process methods in a little bit, so I won't spend a lot of time on that. So, and then because this thing returns failure, we know that the entity configuration failed. Now, this is not a meta object, so the failure of the unit not configuring, well, actually, the unit doesn't configure. I think the unit is actually removed from the scenario. So I could say accepted anyway and continue, which I think that's what I'm going to do. I'll say yes. So I'm going to get this error message. Then I'm going to go ahead and run. And so you can see that, because the unit was not configured right, I'd forgotten about that. The unit is just gone from the scenario. So even though I accepted it, it failed, and nothing will run for the unit. So I misspoke there a second ago and thinking that the other models would execute. They won't. If I return configure failure, the whole unit is just gone. Because it's not composed correctly, there's no sense in even trying to run. You might end up causing crashes and all kinds of problems. Composition is not right. So the unit is just basically disabled from the entire scenario. So I'll go back and I'll put that back in, I hit accept, and everything's fine. We now have the unit put back together. So that's the configure on unit method. And we did take a quick look at the configure on unit method for another one of our FEX models. And this is actually more typical because this model interacts with several other pieces of equipment. And this is the way that we can, first of all, make sure that for our own execution, we have the models that we need. But secondly, and very importantly, we can tell the user specifically what is wrong with the configuration and why it is that we don't like it, so that they can hopefully figure out how to fix it. And that's, we try to put out messages there that make it obvious to the user. So the configuration fails, but we tell the end user why. Why is it that it failed? What models are not there that are supposed to be there? Now, let me show you something else real quickly before I finish up with this. I'm going to go in here and I'm going to just employ a different sensor. So I think I have some other sensor meta objects defined in this scenario. Yeah, so here's my blue sensor. And I'm going to hit accept. I have a sensor on this model, but that particular sensor doesn't support the interface. So I get the same error. So it's not just that there's a sensor on there, but it has to be a sensor that supports the interface. So I go to the processing here. I've got some other things on here because the sensor had these three things attached to it. So the sensor's there. So the models are there, but the overall unit has been flagged as being not configured correctly. So that's the configure on unit method. Very important method. Again, I think almost every single cognition model that you'll see coming from Turnitin will have that method implemented. Every cognition model. The only time it won't is if the cognition model doesn't actually interact with a piece of equipment. So we have some cognition models that don't interact directly with the equipment, and they oftentimes will not have a configure on unit method. So there's the introduction to the configure on unit command, a very important command in Flames cognition models. Thank you for listening, and thank you for choosing Flames.